Now let's create Numpy arrays. We're going to start with a Python list and convert that into a Numpy array. Keep in mind, whenever you're going to be working with Numpy, you're going to have to import the library first, but you really only need to import it once per notebook or per project, and I already have it imported here. Just wanted to show you that before we move on and create our first variable here. So array1d, that will equal np, which is our alias for the library, dot array. And in here, I'm going to provide my list. So I could have a list of numbers here. If I go ahead and try to print that out, here we go. We see that this generates an array with these numbers over here. We could also do a multi-dimensional array or a 2D array by nesting our lists. So here we go, Numpy array. Here's our first list. And here's the first row. Let me make sure I close it. Here we go. And 4, 5, and 6. If I go ahead and print that out, here we go. We get our nested array that basically has 2 items. Each item is a row. So we basically have 2 rows in this 2D array. Now, arrays also have attributes that tells us about the data that it contains. So over here, I'll do array2d.size. And if I run that, we get the number 6. So it's basically telling us there are 6 items in this nested array. But I could also do array2d shape, and that will return 2 by 3. So we now know that we have 2 rows. Each row has 3 elements. So that's the shape, and that's the number of items that we have in this array. Now, here's something really important about Numpy arrays. They are uniform. Unlike Python lists, where we're able to mix and match different data types, strings with numbers and objects, Numpy requires us to have all the elements to be of the same data type. And that is kind of the key to their performance. So let's look at the attributes that shows us the data types of the elements that we have. So if I do array2d.dtype or data type, it returns a 64-bit integer here. We could also do array2d.itemSize, and that returns the memory per element in byte. So basically, every element in this array is being stored in an 8-byte memory block. Now, let's see what happens when we mix data types together. If I create a mixed array, and it will contain a number and a float number and just other values as well. If we are to print the array mixed.dtype, oh, this is not a NumPy. I need to convert this into an array first. Now you get that this is a 64-bit float value. And if I try to actually print out what is the value that is being stored here, you'll notice how it converted all the items in this array to all be of the data type float, even if they don't have any floating decimal points. This is called upcasting. It tries to find the common data type that all of those variables can be stored in without losing any information. So let's try it again with if I added a string in here. And if I run this, it converts everything to the common data type that they all can be stored in, which in this case, it's a Unicode string that has a maximum length of 32. If I run this over here, you'll notice how it wraps all of our elements here into quotes, basically signifying that these are now string data types. This design allows NumPy to store data more efficiently and to perform computations a lot more faster than it would if it was just using regular Python lists. Now, if you truly need mixed data types, you could use object arrays, but these are less memory efficient and they run a little bit slower. Or we could use pandas data frames, and we're going to talk about those next week. But for the time being, let's recap what we talked about. You're able to create NumPy arrays by using Python lists. You're able to use attributes like the size, the shape, the data type, and the item size to learn more about the data elements or the data that is being contained in your NumPy arrays. And most importantly, all the data types of the elements within an array has to be of the same data type. Otherwise, NumPy is going to upcast those into something that is common, that is able to contain the data. Next, we'll learn how to move through arrays and to fill them with data.